Hello, everyone. I'm Janine Donnelly, Manager of Webinars for IBM Systems Magazine. And on behalf of IBM Systems Magazine, I'd like to welcome you to our presentation, If It Ain't Broke, Why Recompile COBOL, sponsored by Cloud Compiling. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources. You'll find that on the left side of your screen, and know that you can download those right from the platform without being disconnected from the webinar. Today's webinar features two speakers, Charles Mills and Reg Harbeck, with a combined 60-plus years of mainframe experience. At the conclusion of the presentation, we will have a COBOL Q&A session with Reg and Charles. So at any point during the presentation, if you want to post a question, you may do so in the Q&A panel. So please take this opportunity to ask the experts. So a bit more about our speakers. Charles is the Chief Development Officer for Cloud Compiling. He's been writing mainframe software for longer than he cares to admit. Charles developed security software for 8 years at Corelog, now BMC, authoring the Z Defender and Syslog Defender products. Prior to Corelog, Charles founded a software company that was acquired by ASG, where he spent 3 years in various roles. Reg is Chief Strategist at Mainframe Analytics Limited. He's been involved in IT, including mainframes and COBOL, for more than 3 decades. Reg is also a 2020 IBM champion. He has consulted, presented, written, and taught courses on mainframe-related matters worldwide, and is heavily involved in the mainframe ecosystem. And so, without further ado, Reg, I'll turn the presentation over to you.
Thank you, Janine. Looking forward to talking about this really interesting and compelling topic today. We're going to begin by taking a look at the whole concept of technical debt and understand what it is, and especially from the perspective of the particular technologies in question, COBOL and the IBM Z or Z mainframe. Take a look at the history and how their strengths actually led up to a challenge, a problem, this debt, and specifically how recompiling has become that debt. We'll take a look at some of the issues then surrounding recompiling and why it's a problem, why people haven't gotten around to it and may be reticent to do it. But then some of the implications of not doing it and some of the advantages of doing the recompiling. And specifically then afterwards, look at strategies for preempting that. And then we'll move on to some further discussion and presentation by Charles. So to begin, let's take a look at COBOL, the Common Business-Oriented Language. Well, COBOL is not the first programming language. Of course, the very first programming languages were basically machine language, which still exists on all computers, but which in the early days, people had to enter in first using flip switches and then using punch cards. But punch cards actually predate modern computing. In fact, the original punch cards were introduced by with an electronic loom back in the beginning of the 19th century by Jacques, and then that idea was perpetuated by people such as Babbage and then Hollerith. But by the time that IBM was founded and named and well established, they had punch card business and punch card machines that were very much part of their business, and they stabilized or settled on an 80-column wide format in the 1930s. So that by the time World War II was over, punch cards and punch card processing was an extremely common part of business, but it all used numbers. Printable alpha characters were not common or were not in use. And so then an important thing happened in the history of computing as electronic computing was being developed in its very earliest days at the end of the 1940s. A Jesuit PhD priest named Father Roberto Busa met in 1949 with Thomas Watson Sr. and convinced him that they should have alpha characters and not just numbers on these punch cards. In fact, apparently, as the story goes, Watson was initially resistant to the idea and saying, it's impossible. And Busa happened to have just grabbed a an advertising punch card that was sitting in the lobby in which was written, "The difficult we do right away, the impossible takes a bit longer," and convinced Watson that it was worth trying to put alpha characters on the punch cards, which he therefore agreed to, and which therefore became part of the history of computing. And within a couple of short years, a lady named Grace Hopper, who eventually became Rear Admiral Grace Hopper, was inspired with the idea that now that you could use alpha characters, why not use them for creating computer programs instead of using switches and numbers to treat computers as just glorified calculators. And so she invented the concept of a compiler. And the compiler had two really important aspects to it. One is that it was in a human-like language, more to the point, an English-like language, and so that you could write stuff up in an intuitive manner rather than just using numbers. But second, that in doing so, you could write a program that would be compiled for one platform, and then just create a brand new compiler for another platform, and have the same program recompiled without necessarily having to change it. And this was a really important moment in the history of computing, because now, once you wrote a program, you didn't necessarily have to rewrite it or change it in any way. You just would recompile it. So that led to the whole idea then of source code that was platform independent, that the program existed separate from the computer it ran on. And so then by the end of the 1950s, the group that put together the COBOL language, which was led by Grace Hopper, was designing a language that met all of the criteria that had been formed and understood over the previous decade. And the criteria that this programming language had to meet were business criteria. So it had to do things such as decimal math and not just the binary math, which is natural for computers, because decimal math, without errors being introduced by artifacts from conversion, was really important for financial and such matters, and displayable characters, because those are how we do business. And so those two factors were a really key part of how COBOL was designed and how it thought. And then move forward to the next really important innovation that built on that in many ways was IBM's announcement on April 7th, 1964, so basically 4 or 5 years after COBOL was being designed, of the System 360 mainframe, which became the progenitor to all modern IBM mainframes. And some of the important thinking that went into that, on top of the design thinking that went into the creation of COBOL, was thinking about the fact that until then, every time a new computer came out, you had to at least recompile, if not rewrite, all your programs. And especially if those programs weren't written in a high-level language such as COBOL, there was a complete rewriting was necessary. And so that kept everybody kind of bound at the technical level and not really moving up to grander application ideas. So IBM designed the System 360. In fact, they designed 6 models of the System 360 to be able to run exactly the same programming language, to have the same architecture, and then made a promise that any program you wrote for any one of those computers would run on all of them and into the future. And they basically kept that promise over the past, 56 years now. So what that meant is that now you could write a program once and then build on it rather than having to rewrite it every time a new release of the computer came out. But there were other issues even back then, and especially back then, including that the resources were not that available. In fact, the address space, the averaging range in the 1960s was 3 bytes or 24 bits worth, which is 16 megabytes, and none of the original mainframes had that much real memory. It was not available yet. And so the need then was to be very frugal with all the resources that were available. And so that became part of the culture right from the very beginning, the culture both of the mainframe people and of COBOL programmers, because although COBOL was not designed specifically for the IBM mainframe since it predated it, it was a perfect match for the mainframe. And the ideas that fed into one fed into the other, so much so that I've often asserted that the COBOL and the IBM mainframe instruction set look like twins separated at birth. They think so similarly. They have such important similar emphases. And so then we have that growth of the two together and optimization together over the many decades since then. Each of them has continued to advance and be enhanced. And so we see, for example, on today's modern IBM mainframe, that it has some amazing advancements, including vector decimal math instructions that just make it go lightning fast with important calculations such as the decimal calculations that are so important to COBOL. But meanwhile, while all these things are happening, one thing that wasn't happening is programs weren't being rewritten because they didn't have to be. A program that was written once and worked well enough ain't broke, right? And so there were a lot of COBOL programs that had been written once and then maybe compiled once for the mainframe and might not even be being recompiled, certainly not needing to be rewritten, because instead there's the opportunity to build on them and build more and more code rather than just writing the same old code over and over again. But the issue is that although on the one hand, as the mainframe hardware continued to advance, there are a lot of features that became enabling for even programs that already existed. There were some features that you had to recompile in order to get an advantage from them. And so what would happen is some of these optimizations, such as the vector decimal math, don't work unless you have explicit invocation of them in the instructions of your program. And so you may have compiled with the old style instruction set. That's not going to take advantage of that. In addition, there are other advances that have continued to be made in the compiler over the years, including some modern advances such as the ability in the compiling to identify weaknesses in the code and then say, hey, you can improve your code this way, to take advantage of architectural enhancements that have been introduced in the mainframe hardware, and just in terms of the amazing optimization technology that has gone so far beyond merely translating words into machine language to really deep thought, if you will, optimization of how the program flows so that it takes maximum advantage of the architecture and of modern understanding of how to really do things well. Then there's the whole issue of support. Because although COBOL was created in the 1959-1960 range, the fact is that it is not standstill, and the compilers that are available have gotten better and better and better. But for that to happen, older compilers have to get stabilized. And so what that's meant in terms of the IBM mainframe is that the IBM COBOL compiler, release 4, or version 4, has become old technology compared to the modern version 6 compiler. And because of various factors, such as the large amount of code in version 4 COBOL and the pandemic, among other things, the IBM has been somewhat generous in not stabilizing it too quickly. They have already stabilized version 5, which is sort of an intermediary version. But eventually, they are going to have to stabilize version 4 because version 6 has been out there for a while now. And so once you've got your compiler stabilized, your code may still run, but it's not exactly supported. So if anything happens, you really do want to be able to have it available as compiled with a supported compiler. But that doesn't change the fact that frugality remains the name of the game. In fact, it's returning across computing right now. And it's sort of funny that, we as the mainframe organizations can say welcome back to the rest of the world to frugality, because we have always on the mainframe had more demand for our mainframe than we had dollars to pay for. And so everything has always been optimized to make sure we got the maximum value from our mainframe investment. And that pressure has always existed. But in other platforms, they've sort of been riding Moore's Law for the last 55 years. Well, the problem is that Moore's Law, which was invented by, or discovered, I guess you could say, by Intel co-founder Gordon Moore before he founded Intel, was basically that the number of components on a given amount of space of integrated circuit technology seemed to double every year or so, and that eventually got generalized into a number of different aspects, from CPU speeds to storage density and such, doubling every 1.5 to 2 years, and that has been consistently the case for about 5 decades. And that suddenly we have people such as the CEO of NVIDIA proclaiming that Moore's Law is dead. And we see that evidenced in things such as CPU speeds, where basically processor speed has stabilized around 5 gigahertz for basically over a decade now. And what that means is that relying on hardware to pick up the slack for sloppy or inefficient code design is no longer an option. And so everybody else in the non-mainframe world is sort of starting to rediscover what we have never stopped doing, and that is frugality, and that's becoming more and more important. So then the issue is that on the one hand, on the mainframe, we've always been that frugal. On the other hand, the pressure continues to be more and more frugal, more and more cost effective, because that has always been one of the strengths of the mainframe and one of the things that's continued to be built and advanced. So one of the ways that we have continued to build and advance that, or more to the point, one of the pressures that we've had is that the mainframe is built very exactly according to the amount of it that is being used versus just how much you buy. So with other platforms, you might just buy a box and then be licensed by a number of CPUs in a box or something of that nature. But because the mainframe is so exactly measurable, it is therefore also that exactly chargeable. And this is one of the great innovations, in fact, that IBM came up with even before the advent of electronic computing with their punch card machines. In fact, during World War II, IBM created a very large number of very high-end punch card machines for the US military to use in their prosecution of the war. And when it was over, those were returned because they were on lease, they returned to IBM. And so IBM had this innovative idea that rather than merely cutting the price of all their advanced punch card machines, what they would do is reconfigure their most advanced punch card machines to function like a less advanced punch card machine so they could sell it for a lower price to a market that was able to accept a less expensive punch card machine. This same innovation then has continued to be a part of the thinking in the most advanced technology that IBM produces, so that with the modern mainframe, likewise, you buy a mainframe and it can have quite a substantial capacity in terms of hardware, but that IBM can then configure your mainframe so that you're only using and only paying for what you need rather than using the full capacity of that. And so we have programs such as, for example, the rolling 4-hour average measurement giving us a picture of usage. We have tailored fit pricing that IBM offers now, which allows you to basically shrink wrap your capacity to the actual historical usage of your mainframe, and a number of other innovations that IBM continues to create in order to maximize and optimize the efficiency of the cost of the mainframe, so you really do pay for what you are using. And then that payment for what you're using shows up in what you pay for the hardware, and what you pay for the software, and what you pay for ISV software. And so what that means then is that optimization leads to a feedback loop where people are more and more careful about their mainframe costs because everything affects everything else. And so the ISV software billing based on the capacity you're using of your mainframe goes up as your capacity increases, especially if that capacity increases on the legacy side of the mainframe versus the zip-enabled side, which is capable of running newer workloads such as Java. So that capacity usage then is going to increase over time, and that's one of the important things that we in the world of mainframe sometimes don't admit to ourselves, is not only is the mainframe not going away, but it is continuing to increase its really definitive role as a system of record for the world economy. And so as a result, on the one hand, COBOL programs that are already out there are being used more. We know some examples from government organizations that have had, over the pandemic, a need to substantially increase the volume in certain of their COBOL applications, but also adding new features. And each one of these can add more workload to the COBOL that is being run, but also adds to the compiling, because as you enhance it, of course, you're doing more compiling. And as we will see, there's more than one kind of compiling even with a given release, because if you want to really get value from a program, you can up the optimization and really up the performance, but also increase the compile time. So as we see the opportunity to take on these new workloads on the mainframe, we have to recognize that there is inevitably therefore an increase in the amount of mainframe CPU and other resources being used to proceed with these. So what are the implications as we now move into IBM's COBOL version 6? Well, they've already got 3 releases, if you will, of their COBOL version 6. And starting out with version 6.1, we already see that they have introduced a substantial capacity to compile and optimize very large COBOL programs. And one of the ways they can do that is because they've expanded to using 64-bit addressing. So as I mentioned earlier, the original mainframe only had 24-bit addressability, and that gave you 16 megabytes of space to speak to. That was a lot in the early days. It was a lot more than the 640K that Bill Gates famously proclaimed should be enough for anybody. But as we discovered in the history of the mainframe, by the end of the 70s, we were having trouble fitting inside that 16 megabytes. And so the XA architecture came out with 31 bits of memory. And of course, that was 31 rather than 32 because we have that extra 1 bit that would toggle on or off depending on whether you're using the full 4 bytes of addressability or just the original 3 bytes. And as we all know, the delineation between the original 16 megabytes and the remaining portion of that full 2 gigabytes was known as the line. So by expanding that, that gave a little bit of breathing room, but eventually we needed more elbow room. And so about 2 decades or so ago, maybe 2.5 decades ago, IBM opened up to having full 64-bit addressability. And during that time since then, before that, of course, there was the hyperspace. And then about 2 decades ago, we had the 64-bit addressability. And the problem is that adapting legacy to new innovations sometimes takes a while. And so there's been a slow, very careful progress to taking advantage of that addressability. And so now we see that the COBOL 6 compiler has done that with the ability to compile with address mode 64. So it's able to use the full 64 bits in doing a compile. In addition to that, there are a number of other things that were introduced to the COBOL programs themselves, including the ability to dynamically allocate and free memory. Then moving on in 2017 to COBOL 6.2, we see that there are further enhancements for compile time, runtime performance, various information, and exploiting of a new feature that was introduced in the Z14 or Z14 without code changes, just by recompiling, of the vector-packed decimal facility. And so this really important enhancement to the mainframe hardware basically allowed for this decimal math to be done faster and faster without any changes to the code, as long as you recompiled. And now we arrive at 2019 and version 6.3 with the IBM Z15 or Z15 mainframe having some amazing advanced features, and using this compiler to be able to recompile COBOL programs and have them run in specific decimal calculation scenarios at 100 times faster for the same program. As you can imagine, that is saving a lot of resources, a lot of CPU. And even in a realistic situation where you're only doing some decimal math and it's not all you do, still a substantial improvement of 20% faster in a realistic environment. But another really important thing that happened is now that A-mode 64 is not just part of the compiler, it's being opened up to the COBOL programs themselves. And so what that means is now we have the opportunity, as other systems on the mainframe become available and able to use a 64-bit addressing, that the COBOL programs that have been compiled with version 6.3 can have that feature open up so that they can interact and use that gloriously vast amount of memory that 64-bit gives you. And of course, at the top of the 16 megabyte space, we called that the line, and the top of the 2 gigabyte space, before we moved on to this vast 64 addressability, we call that the bar. So that said, let's take a look at some of the implications of these advancements. First thing, of course, is all you got to do is recompile a program. That's it, just recompile it. And so you might ask yourself, well, why wouldn't I just recompile all of my programs and take advantage of all this amazing advancements? And you know, it brings all these features, all these benefits, all the efficiency. And in fact, it's like Moore's Law brought back to life. That somehow, even if the hardware is starting to stabilize in its advancements, the optimization technology in the compiler, paired with the new instruction sets in the mainframe hardware, it is creating this amazing advance that is sudden and extreme beyond a doubling, so that we have that long-term gain. But the short-term pain is significant. Because, first of all, even if the compiler were just running the way it always has in the past, that's a lot of compiling. You've got a lot of programs. If you take a look at your environment, you have probably tens or hundreds of thousands of COBOL programs. You know, it's easy to overlook when people talk about, you know, what is the coolest, newest language, and they give all these lists. The fact that COBOL will always be the greatest language. It's the Mona Lisa of computer programming languages, partly because there are so many lines. You know, I think the latest count was over 200 billion lines of COBOL out there running the world economy. You know, and each organization big enough to have a mainframe has many, many COBOL programs and many, many lines of COBOL. And so if you're going to recompile your programs so that they are running in a supported release of the compiler, then that's going to be a lot of compiling even without the optimization turned up. And then, of course, in addition to that, as we discover the end of Moore's Law, and as organizations start to look seriously at what are the advantageous platforms and contexts for writing new enterprise and world-class applications and start rediscovering the mainframe, we can reasonably expect to see more and more applications developed right to begin with for the mainframe, and that means more compiling. So here's the issue, is as you start to recompile, this becomes an ongoing journey. You've got thousands of programs and you're developing more. And as you add in the optimization, with the compiler, that's going to start using a lot of CPU. And so suddenly that shrink wrap that you put around with your tailored fit pricing, that just shrink wrapped exactly around your historical usage, is going to start to inflate as you start to compile more and more. And that is going to impact your software bills as well as your hardware IBM licensing bills. And that increase in bills can be so significant that it can become a showstopper. Because what can happen is that the organizations that are doing a lot of compiling may not have allocated the budget money to cover the cost of compiling. And so in a really funny kind of way, the short-term pain can actually outweigh the long-term gain, even if the long-term gain happens really shortly afterwards, just because the cost of the compile, especially if you're doing real optimized compiling, and especially if you have programs that are really big and a lot of them, gets so expensive. So what do you do about that? Well, what do you do in terms of dealing with, on the one hand, the opportunity to recompile, make sure you're on a supported release of the compiler, make sure that you have programs that aren't just sitting there uncompiled, untouched for decades, but rather you've got them compiled and current supported, are taking advantage of the current optimization of the compiler, the current hardware advances, without blasting through your CPU capacity limitations and through your budget. Well, one traditional approach to this is what's often called the penalty box. And that is a very special little tiny mainframe that you set aside for just specialized expensive workloads. And then you put your compiler there and nowhere else. And you force people to only run their compiles on that one little penalty box mainframe. And depending on how you do that, that can create some technical challenges and even have to require cultural challenges, including changing people's JCL and other sorts of things in order to force them to get it into that one place so that it's not blasting through your licenses and increasing your capacity on any of the other mainframes. Well, organizations do that. It's one approach. Another approach, which is less about getting your own little mainframe, but rather putting a really low ceiling on compiling, is to configure WLN, workload manager, so that you can only do so much compiling and only when the CPU is not overly busy. So take advantage of the troughs. So when the CPU slows down, then you can do more compiling, and when the CPU gets busy, then you can block or really limit the compiles. And that sounds like a really attractive approach, but of course, every approach has concerns that you want to take into account. And in this case, the concern would be that you would have to wait for backlogs if you do a lot of compiling. So let's say you're recompiling an entire application, because you probably don't want to just recompile one or two of the programs in an application to be with a given release. You want the whole application to be with the same release of the compiler, ideally. And so you could have quite a backlog of compiling sitting there queued up waiting to run. And that obviously is going to be a bit of a challenge. One other strategy then that can help you really avoid such big spikes is to find a trusted partner who can help you offload specifically the compiling workload to a trusted place that then allows you to keep your CPU from spiking, get your programs compiled so that they are able to take full advantage of the modern instruction set and optimizations, and keep your ceiling, your rolling 4-hour average at a manageable level. So having taken a look at that whole background and that whole context, I would now like to turn you over to my colleague Charles Mills, who will tell you a little bit about one of these solutions that responds to these scenarios. Charles, over to you.
Well, thank you very much, Reg. Thanks for the introduction, and thanks for the great presentation. That's really interesting. I love that story about Father Busa. And yeah, you've given me a great lead-in here. Simply put, this is what we do. We solve that CPU spike problem by giving you the opportunity to move your compiles off of that box where you're paying for all that ISV software and put it onto our box. We've got software that does that seamlessly, moves it over onto either a small box of yours or more likely onto a box of ours, and puts that burden on us and reduces your rolling 4-hour average spikes and lets you save some money. That's just what we do. We're really seeing these dramatic increases in the recompile times. I'm not sure if that graph there is something of an eye chart, but we're seeing. Let me get my Excel spreadsheet, the right Excel spreadsheet up here. That one on the left, that is a program with about 5,000 lines total, about 3,000 lines of procedure division. In our benchmark, Enterprise COBOL 4 compilation with no optimization used 1/4 of a CPU second. With V4 optimization full, it used 1/3 of a CPU second. So there's one important thing you see is that with COBOL 4, turning on optimization has almost no impact on CPU utilization. Going to version 6, though, with opt0, which is that middle bar there, that goes from 1/3 of a second to 2.5 CPU seconds. So it goes up 8 times. And with opt2, where you're really getting the benefits, it goes up 27 times to, 8 3/4 seconds. Now, it's really variable. Obviously, we picked the cases here that demonstrate what we're trying to tell you, but that is not the worst one. That program on the right there is a 52,000 line program, is about 34,000 lines of procedure division. About 2.25 CPU seconds to compile it with Enterprise COBOL version 4. About 2.5 CPU seconds if you turn on optimization. Again, very, very tiny impact from optimization. But you go to version 6, and now the CPU time jumps to 9.5 CPU seconds. And you turn on optimization at opt1, it jumps to 15 CPU minutes, 364 times. And we have CPU time costs just like the rest of you. I did not even bother to benchmark opt2. I'm afraid the compile might still be running. So you see these tremendous costs from going to version 6. Now there's tremendous benefits. Your version 6 your existing programs aren't going to run significantly faster on a Z14, a Z15 than they are on an old Z9 unless you recompile them, because the inherent CPU is just not faster. The only way those programs run faster is if you take advantage of the new instructions. And the only way to take advantage of the new instructions is to recompile them with optimization. So that's why you're kind of in this box here on recompiles and CPU time. So there's the impact. Now, how do we help you with that? We've got 2 scenarios. We call one of them private cloud. Now, this is if you've got a large shop, you've got multiple LPARs, you've got big LPARs, you've got small LPARs, what Reg called a penalty box. You cancel the IBM compiler licenses on those big machines, on those big LPARs. You consolidate the licenses on the small LPAR. You install our software. It seamlessly routes the compiles. No JCL changes, no tweaking of workload manager, no additional products like throughput manager or anything. It just routes all the compiles under the covers to that one machine. So you pay IBM compiler licenses on one machine, the smallest machine, with no impact on your costs for DB2, your costs for your CA products, and so forth. The other scenario is what we call secure cloud. And this is if you don't have a penalty box that you want to use, you can move all your compiles to our machine. It's exactly the same scenario technically, The software, which I'm responsible for, barely knows the difference between the two. It's simply capturing compiles in one place and, excuse me here, I'm getting a frog in my throat. Captures compiles in one place and moves them to another machine. You move them to our machine. Obviously, you no longer have any IBM compiler license fees at all. You have only our cost, and that's a guaranteed 50% cost savings. Now, let me digress onto that a little bit, that cost savings. Now, every software vendor, right, has the same model. Give us $100,000 today for a license for our wonderful product, and oh gosh, it's going to be great. You're going to save lots of money in the future. You're going to save so much money, you aren't going to know what to do with it all. It's a great model for software vendors, but it's not our model. We don't think it's a good model for customers, and it's not our model. Our model works like this. You pay us $0 up front. There is no $100,000. There's $0 up front. You cancel those IBM software licenses or compiler licenses, and then you pay us half of what you used to be paying IBM. It's a pretty simple model. You don't pay us until you start saving, and it's a guaranteed 50%. It's not like, well, gee, after a couple of years, you will have made up that $100,000. So I say here to our data center, I'm supposed to emphasize that we actually have 3 data centers, so we've got some redundancy there. We have 2 production data centers, and we do our development at the IBM Innovation Center in Dallas, Texas, which brings up an important point, does IBM bless this? Yes, IBM seems pretty comfortable with this. We're IBM Partner World members and so forth. We develop at the IBM Innovation Center and so forth. This is not something that's going to earn the ire of IBM. So we go on to, how does that work? The case for compiling as a service is pretty simple to kind of summarize here. The license charges can quickly be the biggest cost in your shop. Moving some of those costs off of your machines and onto our machines reduces that rolling 4-hour average. It just makes perfect sense. There's no data migration. There's no changes to your programs. There's no training. You don't have to train people to use the software. Your application programmers, half of them will never notice the difference. They'll never realize that something different is going on. No change to their processes, no changes to their JCL. Doesn't matter how many compile procs you have. There's no changes. There's no ZOS changes. There's no hooks. There's no IPLs. There's no SVCs, none of that stuff. And emphasize, it's the same IBM compilers you're using now. This is not, we compile on Windows or something like that. Our data centers are running ZOS just like you are. We're running the same compilers you are. We run your code through the same compilers you do. But it's just our compiler's license, not yours. And that's that licensing model I talked about. There's no upfront investment. You pay as you save, and there's kind of minimal risk for you as a result. So that is pretty much it for what I'm going to say. I put a slide up here with what our customers say. I will turn this back to Reg, and Reg will take your questions, and I will try to answer them.
Well, great. Thank you so much, Charles. First, just want to remind people, we see a good number of questions already in the Q&A, so we've got a lot of great questions to answer. But just a reminder to everybody else, if you have questions, please do put them in the Q&A. Just a couple follow-up questions from myself before I go to the questions from the audience members. First of all, Charles, so this seems like a relatively new approach, and yet I understand you folks have been doing this for quite a while. Tell me, how long have you been doing this sort of thing?
Reg, good question. We've been doing this for almost 20 years. We've had this product and a predecessor product in the market since right around 2001, if I recall correctly.
Okay, great. Now, I talked about the upfront pain and long-term gain, and really, given and we have a question about this coming up, given the fact that IBM hasn't stabilized COBOL 4.2 just yet, why the urgency? Why now versus some other time? And Why is this something that an organization should be looking at dealing with right now versus continuing to put it off?
Well, yeah, IBM has pushed back the sunset date on the service now. There's a great IBM Systems magazine article on this about the IBM portal and so forth, has pushed the date back to April of 2022. Now that sounds like a long ways away, but 2021 is right around the corner. 2022 isn't very far away. So I really think it's really time to start thinking very, very seriously about this. We're seeing, and we're seeing more and more outsourcing of various sorts. There's greater and greater acceptability of outsourcing. There's greater acceptability of enterprise data in the cloud. And essentially what you could think of cloud compiling as is a niche outsourcer, a very specialized cloud outsourcer, a way of moving one very small part of your workload into the cloud at no risk, but with a potential substantial cost savings.
Okay. Now, given that, how do you stay up to date? How do people know that if they're using your solution, that they're using the full range and currency of the compiling that they need?
Yeah, I'm sorry, Reg. I was looking at the questions here and coming up, and I didn't. I'm sorry. Repeat that question,
so
please.
How do people know that you're staying up to date, that your technology is staying current and meeting their needs?
Yeah, it's a good question. Obviously, that's a tremendous focus for us, staying current. Because we're in the COBOL business, it would not do us very much good to be in last year's COBOL business. We are members of the IBM Partner World. We are non-disclosed by IBM on future developments, what IBM calls confidential disclosure group. So we're aware of what's coming in COBOL, even things that haven't been announced. So it's just very important to stay up to date with that. I mean, we started out 20 years ago. I think Enterprise COBOL was at version 3, and we're now supporting Enterprise COBOL 6.3. So we're staying pretty well current with this thing.
Okay, I'm just going to ask you one more of my own questions before we go to we have a great selection of questions from our attendees. And that is basically, what is your advice for applications managers who are just starting this process of recompiling and haven't really begun to migrate to version 6? What do you foresee for them, and what would you advise to them?
Well, it's like everything else, Reg. Planning is the key. You've got to, identify a general strategy. Are you going to recompile every program? And if not, how are you going to identify the ones to do first? Are you going to do that based on risk? Are you going to do that based on difficulty? Are you going to do that based on where the potential savings seem to be greatest, and so forth?
Okay, so let's take a look at the great questions that people have been asking. And the first one you kind of already answered, but I just want to get an explicit answer. When is the sunset date for COBOL 4.2? Yeah,
there's the IBM portal that's referenced in that Systems Magazine article, has all the sunset dates out there. The current date is April 30th, 2022, but 2022 sounds like a long ways away. That's a little over a year away. Extended support will be available if you want to pay IBM extra money for the privilege of staying behind the times. There's extended support beyond that. And of course, it doesn't mean all your COBOL 4 programs are not going to stop running. It just means if you have to make an emergency fix at 3 in the morning and you run into a compiler bug, IBM is probably not going to take your call. So that puts some urgency on trying to get as much off of COBOL 4 as possible.
Okay, great. So our next question is, does COBOL 6.3 deliver much CPU savings compared to 6.2 on a Z15?
Is 6.3 a whole lot faster than 6.2? That's going to be an it depends question. And I would be kidding you, Reg, if I said I knew the exact answer to that. It's obviously going to depend on the particular program. They're making more and more use of those decimal vector instructions, which are just incredible savings, but that doesn't apply to every program. And what have they done from 6.2 to 6.3? IBM does not share the exact details of, in 6.2, we compiled this source code to these machine instructions, whereas in 6.3, we compile this source code to those machine instructions. I think generally, if you're going to undertake this effort, you might as well undertake it for 6.3. There's just no point in getting up to a current version of COBOL that isn't quite current.
Okay, next question here. What do you recommend as the best way to measure the improved performance of Z or Z13 COBOL, it says 4.3, to now a Z15 COBOL 6.3?
We're not supposed to talk about COBOL 4.3. That's a secret. No. COBOL 4.2, Reg. You've let the cat out of the bag. COBOL 4.3. No, COBOL 4.2, I mean, the only way you're going to be able to tell is to benchmark it in your shop. I mean, every program is different. Every mix of CPU and I/O is different. The only way you're going to know is to benchmark. And you may have some programs that have a certain amount of commonality. You may guess, well, we're an insurance company and all these programs that process actuarial tables, it looks like they're very compute intensive and we gain a lot from COBOL 6. Or, this program is very much I/O bound. We're not going to gain much from converting to COBOL 6. You're going to have to benchmark in your shop.
Okay.
Unfortunately. I wish I had a magic answer.
Fair enough. That's that famous old IBM answer. It depends.
That's right.
So next question, what are the dangers of implementing a from now on approach? For example, anything that gets changed from now on gets a new compiler.
I would not do things that way if it were me, Reg. Reg, I'm a software architect. I'm not an application development manager. But it would seem to me, you've got to change with a deadline and a budget and so forth. It's the wrong time to take on a bunch of additional risk. What if this program behaves differently under COBOL 6? If it were me, I think I would make a separate project out of getting current with COBOL 6. And meanwhile, if I had a bug to fix or a regulatory requirement or something like that, I would probably do it with the old compiler.
Okay.
But I'm not an application development manager.
Sure.
Sorry, go ahead.
Next question. By faster, do we mean elapsed time or CPU time? And I would say probably both, but I think there's probably an important point to be made of distinguishing them, if you care to do so.
Yes, by faster, we certainly mean primarily CPU time. CPU time is where your costs are. On the other hand, your batch window is constrained by wall clock time. So both of those things are important. Saving CPU time is going to save elapsed time, but the two are very different. If a program is very, very heavily I/O bound, if somebody's doing, random VSAM reads and updates, then saving CPU time is probably not going to make the program run a whole lot faster. On the other hand, if the program has, is computing actuarial tables, then saving CPU time is probably going to make the whole program run faster.
Good points. Okay, now here's an interesting one. What is automatic binary optimizer, and is it needed to upgrade the old COBOL version to 6.3?
We haven't talked about automatic binary optimizer a whole lot, and it's a product that cloud compiling is certainly looking at offering on a cloud type basis. It's a fascinating program. It is a unique program, and I'm going to stand here and pitch an IBM product a little bit. It is a fascinating product. It is a unique product. What does a compiler do? A compiler translates source code into object code, right? That's the definition of a compiler. A Fortran compiler takes in Fortran source code. A COBOL compiler takes in COBOL source code. An assembler takes in assembly language, and they all produce object code. The ABO is a compiler. It comes out of IBM's compiler team in Toronto, and it's a compiler but the input is object code. It takes in old COBOL object code and produces new COBOL object code. So it's a fascinating product, and it is certainly an alternative to recompiling everything. IBM claims this minimizes your need to retest and so forth. I'm not sure I buy that part of the story. It seems to me that if I was running a company, that I would want to, if I looked crossways at a program, I would want to retest it. But that's what the ABO does. It's an alternative to recompiling, and it's a very, very interesting and unique product.
Cool. Yeah, and then the second half of the question, of course, is, is it needed for 6.3? And I'll add my 2 cents worth that if you actually have the source and it's the proper source for the COBOL programs that you're running, and you compile that source, then you don't need the ABO. But the ABO is useful in cases such as when you aren't sure that your source matches your executable, and you don't want to take the risk of compiling the wrong source, or for any number of other reasons, but that it's an alternative to using the 6.3. Anything you'd like to add to that thought?
Right, and I think the COBOL migration portal makes the point that you could also separate programs that are stable. You say, gee, we haven't changed this program in 20 years. Well, why not just then run it through the ABO and be done with it? On the other hand, a program where you're making changes every week, every month, every 6 months, you might as well get that converted over to COBOL 6. There's not much point every time you make a change, making that change to COBOL 4 source code and then ABOing it. And I suspect, I don't know this, but I suspect the compiler produces better results, that the compiler can do a better job of optimizing source code than the ABO can do of optimizing old object code. I don't know that, but I suspect that's true.
Okay. Now we have another, all these are really interesting questions. Here's one. We have a discussion among us about a COBOL version 4.2 and a COBOL version 6.2 program. Can they be in the same unit of work?
Can you mix COBOL 4 and COBOL 6 into the same executable program? Yes, you can. There's some limitations, of course. One of the big issues is some of those old COBOL 4 programs are A mode 24 because they call assembler subroutines that need A mode 24. There's a lot of restrictions, and I would be cautious with that. I would not just go charging off and say, "Oh, Mill said no problem." But the basic rule is yes. You can mix and match that.
Okay.
Either static links or dynamic links, you can mix and match.
Excellent. Now here's one that's kind of related to that. Do we need to change any code if we have to recompile?
Yeah. Oh, yeah. Let me something. I think go back to that ABO question. Is ABO needed? No, ABO is not needed. ABO and COBOL 6 are independent products. You can use one and not use the other either way. Okay. Can I repeat this question, Reg?
Sure. Let me just look at the. Do we need to change any code if we have to recompile?
In theory, COBOL is pretty much COBOL. In theory, it's upward compatible. There are very specific things that either have changed. They've added some reserved words, for example. I've forgotten. I had a couple at the top of my head before it. There's a new reserved word. Well, if you've got a data name that's that reserved word, you're going to have to change it. What you want to do tomorrow, if you haven't done it already, there's an Enterprise COBOL 4 option called Flag Mag 4. You want to turn that on, and that will generate a warning message, actually an informational message. You won't screw up your return codes. It'll generate an informational message for everything that it notices that says, hey, I'm good with this, but COBOL 6 will not be good with this. There is your clues for what you're going to have to change. Your changes should be minimum. Your changes should be minimal. But yes, there are potentially some changes necessary here and there.
Okay. Here's one. How would I know how much of the costs we are investing for compile so that we can frame the business case if we have to go down the secure cloud model?
how would we know what we're spending for compiling now?
Yeah.
Is that what you're? Yeah. Well, Chris,
how much would I know for the cost? Yeah. Go ahead.
I mean, that's an interesting question because there's two parts to that cost. Part one, the obvious part, is what you're paying in monthly license charges for the compilers, and that is relatively easy to determine. Now, this is the occult, arcane science of decoding your IBM bill, but in theory, at least, you could look at that IBM bill and say, by golly, here is what we're paying for the IBM compilers. Here's what we're paying directly. A much harder thing to quantify, and really what we're talking to in this webinar, harder to quantify, is, well, if we start doing all these COBOL 6 compiles and we start using 14 CPU minutes instead of 2 CPU seconds to compile this program, what is that going to do to our CA bill? What is that going to do to our DB2 bill? And that is a much tougher thing to analyze. It's an interesting question, and it would be interesting, there are people who specialize in that kind of question. It'd be interesting to work with them and come up with some great measurement tools for that.
Great. Now I've got. Looks like we have time for about 2 or 3 more questions here, if that. But here's the next one. How can you be sure recompiling a 20-year-old program won't cause problems? Very important question.
Oh, I promise. No, you can't. You cannot be sure. I mean, and you can't be sure ABOing it either. I mean, IBM's premise on ABO is, well, you're not really changing anything, so you don't have to test it. I love ABO. It's an awesome product, but I do not buy that claim. You don't know. I mean, you're going to have to test. It is not simply a budget for recompiling. It's a budget for retesting.
And that is so important.
The hope is compatibility here. The hope is compatibility here.
Yeah, and I think a lot of these questions are basically implicitly asking, how simple is it? And the answer is, you still have to have responsible ownership of what you're doing. You can't just kind of go and run something as a panacea and assume everything's fixed. You still have to be fully engaged and taking ownership of the results and paying attention. So that said, with that in mind, here's the next question of that nature. What about the COBOL runtime library? Doesn't IBM charge for them?
Yes, you have to pay for LE either way. Yes, IBM charges for LE, I believe. I'm not an IBM licensing details guy, but you need a language environment in any event. You're paying for a language environment now. You continue to pay for language environment. It's a separate bill from the compilers.
Okay, well, I'm looking at separate our time license here. We got a lot of questions left. It's amazing. And any questions that we haven't gotten to during this discussion, certainly there will be circling back and getting to everybody about those questions. So I think, at this point, given that we're just about out of time here, let me just take a look if there's any more that we want. Okay, I've got one more that I'll ask, I guess. And we'll call this the last question of the day, and then we'll follow up for the rest. And that is, we have all versions of COBOL, 1, 2, 3, 4, etc. How much time consuming is it if we have to just recompile the old versions to 6.3?
Well, I'm not sure the answer to that. It's kind of a how long is a piece of string question. Obviously, you want to. Comes to that point about prioritizing. You want to prioritize those compiles, and you might want to start with the COBOL 4 stuff because that's where you're going to have the best compatibility, and you're going to have considerable bang for the buck. I don't know that COBOL 4 generated much better code than COBOL 3, COBOL 2, VS COBOL 1. So I don't know that the gain is any greater from those, and the compatibility is likely to be a little less. So I would start with COBOL 4 and work backwards, I think.
Awesome. Well, I think we've just about used up our time, and we just have a couple seconds left to pass it back to Janine. So, Janine, over to you. Thank you very much. And thank you, Charles.
Oh, and we will answer these, right? Isn't that our policy? We're going to try to answer all these questions that we didn't get to? Yeah.
Absolutely. So, Janine,
All
over to you.
right. Thank you, gentlemen. I want to thank everyone for attending today's webinar and for participating with your engaging questions. We have so many. So thank you to Reg and Charles for offering to get all those answered, so watch for that. And later this week, we will be sending out a follow-up email with a link to the recording of today's webinar to everyone who registered. So that concludes our webinar. Thanks again for joining us. Have a great day and stay well.